So let's talk about performance tuning, Windows 10. It's part of lesson 6, troubleshooting Windows 10. So we'll begin. So we're going to click on presentation, and here are the slides. So performance tuning, the first thing we're going to talk about is baselining. It's an important concept, something that a lot of people who set up a lot of windows in home and maybe really small offices aren't familiar with, so I thought it's important we go over it. So baselining, to recognize system bottlenecks, you first must establish a baseline that defines normal performance. Windows 10 is capable of reporting on a wide variety of performance indicators. Performance indicators are often called counters. So a couple things I want to break down here. Number one, a baseline is important to establish when you're setting up a PC. We're going to be talking about imaging. We just did talk about imaging, excuse me. We just did talk about imaging. If you're imaging 20 or 30 PCs to be put out on people's desks, it's kind of important that we know what normal performance looks like. What does the processor normally hover on average between? How many, most importantly, what's the memory consumption, what we expect our users to do? So if our users sit down and they run the ERP system or the database where they can, the primary systems we expect our users to run, how much memory does that take, right? To run those programs. If there's 3, 4, the email program, again, some kind of database so they can enter customer information. We're trying to anticipate what the normal user will use the machine for, and what does that machine look like performance-wise? How much memory is it using? How much processor to run certain applications are eaten up? How does the hard drive look, right? These are all important questions because when a user eventually calls, and they will call, complaining that their machine is slow, well, we need to know whether or not that is true or not, right? Or what the normal looks like. If we're supposed to bring it back to normal, it's kind of nice to know what normal looks like, number one. And number two, if they're complaining, it'd be kind of nice to know if the complaint is valid. So, baselining. So we do have Windows 10 is capable of reporting a wide variety of performance indicators, as I said. So the 4 things we're going to really be concerned about is processor, storage, so percentage of processor time. In other words, how much total percentage of the processor ability is being eaten up. Storage, reads bytes per second. Memory, how many megabytes are available. Okay, and then IPv4. We'll talk about that a little bit. However, network tends not to be the bottleneck, and if it is a bottleneck, it tends to be at the network administrator's door. It's at the edge router that goes out to the internet. So, all right. So when you're establishing a baseline, it is important to ensure that you are measuring the normal state of performance indicators. So, nothing over crazy. Now, one of the big things that tend to eat up a lot of memory is browsers, at least nowadays, is browsers. So we often assume our users will have a browser open. So you run a browser, run the, again, whatever applications the company is that tends to use on a day-to-day basis. And then you just take a look, all right? So try not to run too many things. Don't have a query running in the background, or something very active going on, or something that'll take up a lot of resource, because we're trying to get a basic idea. So you measure performance indicators over time. By measuring performance indicators over time, you can see an average value. Again, you're trying to avoid. So we're going to try to get an average look, right? Where average values are less volatile and more accurate than measuring with snapshots of short duration. All right, so that's a baseline. So the point of a baseline, again, is to see what normal is supposed to be. It really helps with troubleshooting machines to know what normal looks like. All right. So the other thing we're going to talk about is bottlenecks. All right, so an important concept in a bottleneck for some folks who've never seen it before So if I had a wine bottle, not that I have one now, that's the fun part about doing these online lectures is, anyway, so if I had a bottle, right, and I had some mysterious purplish tasty liquid inside of it, and I turn it on its side, the liquid would just simply pour out, right? It would take advantage of this hole. Particularly, it would let air come in, but anyway, this is a physics lesson. All right. However, if I put it in a bottle with a smaller neck, like this, right, and then a wider body, all right, like that, right, and I had that same amount of liquid in there, it gets constrained by this long neck, okay? That's what we're talking about, a bottleneck, all right? It's this constraining, it's going to slow down the entire flow, and at the end of the day, that's kind of what a CPU is, or a computer system is, right? We have all our systems, and we have a whole lot of data that needs to be processed, and it's got to go to a processed state, right? If we have a bottleneck, it's going to slow that flow of processing. So that's what a bottleneck is. So again, we're going to focus on disk. We're going to focus on memory. We're going to focus on processor. And, well, we're not going to focus a whole lot, but we'll talk about network. All right. Again, network's very odd for that to be a factor. All right. So let's talk about disk bottlenecks. A disk bottleneck occurs when Windows 10 and running applications want to read and write information to the physical disk in the system faster than the disk can manage. So what we should do is bring up virtual machine. So here we go. So there's a couple things we're going to talk about. This is the one we're used to, Task Manager. They made it a little bit more informational in Windows 10. So particularly if you click on performance, you'll see your processor here. Let's start with this. All right. So disk bottlenecks, normal disk operation. Notice we have multiple disks here because this is our virtual machine. If I click on disk 0, this is what normal disk operation looks like. All right. It's kind of herky-jerky, hurry up and wait is another phrase you might hear. So the important thing to keep in mind is this is what normal hard drive operation looks like. It's going to be a lot of peaks and valleys, all right? Almost like a heart rate monitor, right? So disk bottlenecks occur, the bad thing, when Windows 10 and running applications want to read and write information to the physical disk the faster than the disk can manage, all right? So if we use Resource Manager for disk usage, often we have input and output in bytes per second. And to be honest, this is one thing where I really do like Resource Monitor better. So I'm going to clicked on a little Resource Monitor down here, and if I click on disk, you'll see it right here. I think it's a little bit, it does a better job of indicating what it needs, what's going on in the system. Let's click on PowerShell. I'm going to do a LSLR. And you're going to see a little bit more activity. There you go. On disk C in particular. So you're going to see a lot more disk activity. Even so, it's not killing the disk. It's still fairly operable. I can click on things and they pop up somewhat snappy. Not maybe not as snappy as we like. Of course, that was empty. But yeah, you can see I'm actually still accessing things rather quickly. Right. So again, that's going to be disk usage. When we see a bottleneck, it tends to flatline. It tends to get up here to the very top, and it just simply can't do any better than what it's doing. Let me make this a little bit bigger. Sorry. It can't really do much better. So we're seeing a little bit of flatlining going on up here, but it's over a significant time period, right? And that's what's going on is there's so many read and writes that even though it's doing its best to catch up, there's a significant queue developing, all right? And it's never able to catch up, so it just kind of stays as a flat line, all right? So there we go. This shows current rate of information transfer, highest time active. That's a display of the percentage of time the disk is subsystems active. If that you see a very high active time, then the subsystem may be a bottleneck, even if the disk subsystem has not reached maximum theoretical travel rate. So if you see this number jump up, the highest active time jump up, that might be indicative of Windows misread what the max transfer rate of the hard drive is. And so even though it's not at 100%, it's not fully utilized, it still can't catch up. All right. So possible solutions. Well, for a lot of folks watching this, they're young enough that they've never experienced this, but as you get older, you might visit your doctor and say, doc, really, I play basketball and my back really hurts. What can you do for me? And the doctor will say, stop playing basketball, right? Really step one, a lot of this is stop doing what you're doing. So part of this is working with the user and figuring out what the user is doing, right? Are they running queries the same time they're going out to the internet? Are they, do they really need to do that, right? Are they indexing image files? What are they doing? What's eating up all this hard drive space, right? So again, with Performance Monitor, not so much Task Manager, but with Performance Monitor, you're able to actually see what the most active programs are. These are all background stuff going on, right? But you actually get to see what's eating up most of your disk activity, right? So we can see what's going on. So do we need to run it at the same time as this? Again, that's kind of the stop what you're doing, or do it smarter, right? There is a technology called Windows Readyboost. What you can do with that is you can have a USB flash drive and you can turn it into your swap drive. Virtual memory is what we call it, Windows. So your virtual memory. All right. So remember, one thing that might happen is if our memory, we run out of memory, we don't have enough memory, right? What might happen is Windows may set up. By the way, that's anyway, we'll get to that. So if there's too much memory in usage, what might actually happen is it might. So that's what the hard faults are. You see hard faults. That's how many times it writes the data over to the hard drive. It sets up a swap file, as it's called in Linux, or virtual memory. We segment part of the storage, so part of your drive. We segment that out, right, as part of memory. So even though memory is much faster, remember, 8-lane highway, right? It's a really fast road with the bus. We only have a 2-lane road going to that hard drive. But if we need that memory, we need that memory. So we'll write to it. We'll write our memory to it, and we can read off that memory. All right. So instead of doing that, what you can do is have a USB drive, which actually would be slow. It's like a 2-lane country road with bumps on it. It's actually slower than your hard drive, significantly so. It's like a route in Vermont with lots of 35-mile-an-hour slowdowns, I suppose. But anyway, long story short, the USB drive, you plug that in, you can dedicate that. The whole thing will become a swap file. Will become a virtual memory. So anyway. That would help because now you're offloading work from your hard drive, and again, that's that 2-lane country road. That's a big part of the problem. So you got Windows Readyboost that could help you. You can move the paging file to a non-system disk. Now back to our virtual machine. I think in class I was showing the class this. Well, actually, I can do this smarter. If I right-click on this and go to System. I was about to type in system. That's silly. I go to system info, and that popped up over here. Did I just bring that up on my own computer? I think I just brought that up. This is my own computer, JXPS. I meant to bring it up on my virtual machine. Sorry about that. System. About popping up. I'm just showing you where we can change this setting. So we can tell Windows to, instead of keeping the swap file or the virtual memory on our C drive, which is very busy, again, back to this, if we go back to the disk here, most of the disk stuff, a lot of this is system stuff running off the C drive, right? Explorer, a lot of this stuff is all C drive operations, PowerShell, right? So if I tell it instead of running off the C drive, why don't you run the swap file, or again, the virtual memory. That's under advanced system settings. Not under performance, is it? There it is under. It's under performance settings, advanced, changed virtual memory. and I can specify a different drive. Particularly here, it makes sense to do the stripe drive because the stripe drive is a stripe drive, and therefore it's fast. So anyway, actually, no paging file. Let's go to the S drive. We'll do system manage size. Okay, and now I'm putting it on the S drive. All right. So anyway, long story short, you can change what drive you keep your virtual memory on, which may make sense. Again, if your C drive is very busy doing Windows background services stuff, something about a font driver host, that's interesting. You can always find interesting stuff in here. Anyway, so instead of having your C drive be busy doing this other stuff, it could, and then on top of that be the swap file. You can actually have it onto the S drive. All right, makes sense. So the other thing you can do is upgrade the drive controller. That's a silly answer from the book. We haven't talked about it yet when it comes to talking about troubleshooting. But there is the amount of work to chances of success ratio. This is actually a very vaunted, very low chance of success. Why would the drive? I mean, there's a chance the drive controller is bad or the drivers for the drive controller are bad. It's a small chance, and it's a lot of work to replace a drive controller. So you really want to do that? But maybe, if that's what you isolate the problem to. Upgrade the drive controller, upgrade the disks, go from a spinning platter to a SSD drive, which will have better transactional speed, or go from a 54 to 7200. That'll give you big, long durational speed. So if you have a big transfer, it'll be better. Or implement RAID. RAID 0, RAID 5, both of those help increase speed. Again, that's a lot of work. Maybe your controller controls it, maybe it doesn't. And it'll give you a slight performance boost. Or you could just stop running that query the same time you run the other query at the same time you index photos, right? So, again, different ways to handle it. All right. Another bottleneck is memory bottlenecks. Most memory bottlenecks occur when the applications you are running require more memory than is physically available. So again, what will happen is Windows 10 will use virtual memory, which may not only slow down your entire system because you don't have enough memory, and virtual memory is so much slower than actual RAM memory that it will slow down your system. Virtual memory is a system whereby we already talked about this. Okay, so memory bottlenecks is something we want to keep in mind. Now, memory normal operation, as I had up a little bit earlier, it tends to be straight lines. Okay, let me bring up a good old-fashioned memory eater that we got. Our Edge, and Chrome actually eats up even more. Do I have Chrome installed in here? No, I don't. So I haven't installed Chrome in here yet. So if I click on Edge, Chrome actually eats up more, even though I'm a Chrome user, but so there's Edge running. Actually go to a web page. There you go, Facebook with lots of. I don't think it'll have my Facebook on there, but I don't think I've ever logged in. No, it won't. But anyway, has some media. All right, so I clicked the wrong minimize there. I want to minimize the browser. So right now I'm actually seeing the machine slow down a bit, and look at the memory jump up, right? And it's not going to recover that well. If I close out Edge, it will help a little bit, but by minimizing it and closing it, really doesn't help all that much. I just closed it, and I'm slowly, here it comes, getting a little memory back. It's a process, okay? That's what happens with memory. It tends to plateau. The changes are gradual. It's less spiky, right? By the way, these hard faults per second, that's how often I used virtual memory. So when I had Edge up, Edge running, all of a sudden hard faults went through the roof, right? Microsoft Edge itself, I just had it up there. Sorry. It was highlighted. I saw 10 faults per second. I could sort on that. There you go. Edge was writing over to the hard drive quite a few times. Index got stuck there. Explorer ended up writing to a virtual memory. Again, all that is slowing down my system. If Explorer is running slow, my interpretation is all of the system is running slow. All right. So in other words, there's just too many applications you're running. And by the way, I'm not running too many here, although this is a virtual machine. You can actually see how this, I don't know if you can see it in the video, but you can see how slow the previews are, which do eat up a fair amount of memory. I do eventually recover the memory, much better than older versions of Windows. Older versions of Windows were really bad at recovering memory. But what you want to see is at max your system using 50, 60%. 30% is fairly healthy, especially if you're deploying a new machine. 30% is kind of what you're hoping for, going for. So keep that in mind. Even at normal operation, having all the systems up. All right. So anyway, bottlenecks occur. So that's a memory bottleneck. All right. So possible solutions. This is the one thing that if anyone can do, I do recommend you do it, is increase the amount of memory you can handle. So if your system can handle up to 16 gigs of memory, then upgrade to 16 gigs. It's going to cost you some work and a little bit of money, but it's probably one of the best things you can do performance-wise, at least if you're running a lot of applications at once. That being said, if you can't do that, run fewer applications at once. If you're running multiple tasks, then the more information is kept in the memory. Reducing the number of applications running at the same time reduces the amount of memory used, and consequently the need for virtual memory. Processor bottlenecks. So this is when there's too much work. Again, the processor is the ultimate conveyor belt, right? It's information in, information out. Normally a processor, here we go with CPU, when it runs, this is a very busy CPU. That is interesting. Who is eating up all my CPU? Oh, I know why. Because this is running. I was doing that to generate some hard drive traffic. All right, so once I close that, my processor's less busy. All right, this is kind of more what you want to see a processor do, right? An up and down, heartbeat type situation, a hurry up and wait. That's a healthy processor. Even if you go to 100%, let me bring up Edge again. On the initial load up of Edge, it's going to shoot up through the roof. But there you go. Even if it goes to 100%, as long as it dips back down when it's done loading Edge, that's a good thing. Okay, I can live with that. It's not ideal, but this is actually a fairly busy processor, considering all I'm doing is running Edge. But it's a virtual machine. What do you expect? But the real thing you're worried about is if you see a plateau. If you see a plateau effect, that's going to be disconcerting. All right. We want to avoid this is fairly healthy, right? This is troublesome, okay? Especially when it comes to processor. And you'll feel that. You'll feel that really quick if you see it plateau. So to run multiple applications and perform system tasks, the processor switches between the required tasks very quickly to give the illusion of all activities happening at the same time. When too many tasks are running, or too many tasks must be performed, or an individual task requires too much processing time, the processor becomes a bottleneck. So what can you do about it? Well, find the program that's eating up the most processor clicks and, stop running it, seeing if there's a faster one. Sometimes, so again, what I'm doing here is I'm sorting on CPU usage. Right now, performance monitor is my number one eater-upper. But as you saw earlier, right, I was running, I'm just listing going through the directory. That was eating a good chunk amount of my processor, right? And it quickly shot up the ranks. There it is, right? So I kind of sat there and said, well, I don't really need to run that right now, and I want my system to run faster, so I'll stop it. Okay, and that'll help return my processor back to normal utilization. So again, find out what's using it. Attempt to upgrade, downgrade, replace, or remove offending software. Particularly drivers. One thing you might see, drivers might cause what's called a deadly embrace, where because it's running in kernel mode, there's a more likelihood of causing a infinity loop, or whatever you want to call it, in which the processor gets stuck between two processes and it's stuck in a deadly embrace. So keep an eye on, if you see 100% utilization, check drivers, especially if you just upgraded a driver too. If it's simply a matter of too many programs running at once, attempt to run less. Change to a faster processor. Again, easier said than done, but if you have the motherboard that can support a faster processor, by all means. Add additional processors. Notice this is after change to a faster processor. I rather have one fast processor than two slow processors. Okay, if my motherboard can support multiple processors, fine, great. But there's more overhead, more waste by having more than one processor. It's better to have one faster processor than two slower processors. And then change to a multi-core processor if you don't already have one. Most of us already do, which we talked about. So we've been playing in resource. We've been playing in Performance Monitor. Resource Monitor. That's what this is right here. It's pretty locked down. It gives you quite a bit of information. You can click on things and you can move around. Notice I didn't go too crazy on network. Again, network tends not to. You say, "Oh, look at this. This is at 100%." Again, the scale. By the way, there's just 10 TCP connections. If I open up another and got another TCP connection, let's see, will it ping open up? Let's take a look. Will I go to 11? No, it's not TCP, it's ICMP. Bring up Edge. Let's go to Reddit. What's on Reddit? I guess. Let's maybe not see what's on Reddit. Let's see. I noticed the network jumps way up. All right. So again, network performance, is it a big deal? Is it not a big deal? We're kind of used to it being a bottleneck. It's a natural bottleneck anyway, so don't sweat network all too much. Anyway, so this is Resource Monitor. All right. Performance Monitor is a more powerful tool. We're going to use it in the lab. We can view data from the past generated by what we call counters. You set up these counters. These counters are the things that take a look at the system stats. Counters can be from a local computer or from a network computer. So if you were trying to keep an eye on another computer, see what's going on through the day, can be displayed as a line chart, a histogram, or a report. Collector sets are multiple counters merged into a single data set. Can have performance counters. You can use event trace, so you actually base it off of events. And configuration, which will take registry. You can also configure alerts instead of performance counters, so it can notify you if something hits some level you weren't expecting. Data Manager control the log files and reports generated by those sets. All right. Again, we'll play with that in the lab, but Performance Monitor can be activated by clicking on Start and then Performance Monitor. There we go. There's our sets we're talking about. We can create our own. We have some pre-built system ones. So anyway, we'll play with that in the lab. All right. So I think that covers everything we're supposed to cover. I'll talk to you later. Bye.